This is the result of designing from receiver sensitivity outward rather than from transmit power upward. 5 km ground to ground, 20 km man to drone on standard Bluetooth spectrum. No amplifier tricks, no regulatory gray areas. 2 megabits per second data rate, which means the link budget advantage of -104 dBm sensitivity is not spent just maintaining a weak connection. It is carrying real payload. Drone telemetry, sensor streams, control data, all at full throughput. The STM32 BU7 CCV6 manages both the BLE stack and user application logic on the same core. This means the RF front end and your firmware share timing without an intermediary processor adding latency or link budget overhead. 57 by 47 millimeters. The 140 millimeter antenna is external, which means antenna orientation is a variable you can actually control, unlike integrated chip antennas where the radiation pattern is fixed to the board geometry. Because the link budget was solved at the module level, integrating GNSS, sensors and motor control does not require re-engineering the RF layer. The wireless performance is constant regardless of what else is connected to the ecosystem stack. The RFOXiA Connect app gives you a live view of what the link budget is actually delivering. Map position, signal strength, sensor data. So you can verify real-world range against the physics, not against datasheet claim. BLE chat is a direct consequence of -104 dBm sensitivity applied to mesh communication. Internet independent, no towers, text and voice between Multinav Pro Plus users because the link is strong enough to function as infrastructure. Full open source access via SWD means you can instrument the radio layer directly. If you want to measure actual received signal strength and compare it to the theoretical link budget in your environment, the firmware gives you that access. The integrated RTC is a small detail that matters significantly in time-sensitive wireless applications. Synchronized timing across nodes is what separates a mesh network from a collection of modules that happen to share a frequency band.